exploring exponential models. Right here, I think we've talked about this in the past. We introduced it in Algebra 1, exponential functions. We have y equals 2 to the x, where x is an exponent. That would be an exponential function. I will give you a table of values to use. I'll give you the blue, you have to come up with the red. I'll give you the x values, you come up with the y values. So in this case, this would be an example of an exponential growth. And we'll talk about how to determine whether something's an exponential growth or decay in a minute. But if it is an exponential growth, this is probably the table that I will give you each time. -1, 0, 1, and 2. Does everybody understand how I got 1/2 when I plugged in -1? 2 to the -1, you can't have a negative exponent, can you? Alright, so what do you do? If you have a negative exponent, what do?
You square root the reciprocal.
No. You take what?
The reciprocal.
Yeah, reciprocal. So it becomes 1/2 to the positive 1. To get rid of negative exponents, you take the reciprocal. And 1/2 to the positive 1 is 1/2. Alright. This is the main point that we'll always use, because anything to the 0 power is always what? 1. So 2 to the 0 is 1. So here is the first point, -1, 1/2. Here's the second point, 0, 1. When you plug in 1, you get 2, and 2, 4. And there are those points. And it's growing exponentially. So this would be an exponential growth. Anything rising from left to right is an exponential growth. If your B value, and we'll talk about A and B values in a second, but in this case my growth factor, which is my B value, is 2. If it's greater than 1, then it will always be an exponential growth. If it's a number between 0 and 1, for example, 1/2, it would be an exponential decay, and the shape of that would be like this. Okay? It would be falling from left to right. Yes?
For the y value on the graph, is it just coincidence that they double every time?
Yeah, I think that's because of the 2. Let's see, 3 would be what, 8? 4 would be 16, so it would be
Is
double.
that how you check?
Well, no, that's just in this case, but because your growth factor is 2. Okay? Alright, any questions so far?
What did you say about the numbers with decay models?
Decay would be a number between 0 and 1. Your growth factor, this number right here, would be a number between 0 and 1. For example, 1/2.
Oh.
Okay, and we'll do one of those in a second. Alright, here, write an exponential function of the form y equals a times b to the x for a graph that includes the points 2, 2 and 3, 4. I'll give you a second to write that down. Alright, so this is the standard form of an exponential function, y equals a times b to the x. That's what we were just looking at when we had y equals 2 to the x. What was your growth factor in the first example? What was your b value? 2. What was your a value?
Y.
What? 1. If there's not a number there, it's understood to be a 1. Okay, that is why your growth factor is never going to be negative. If there's a negative in front of the b, so if I had y equals -2 to the x, what's your growth factor? 2. What's your a value? -1. Okay? So b will either be a number between 0 and 1 or greater than 1. Alright, so in this case, where I want to start out, I want to solve for a. I'm going to use either point. I use this one first. And plug 2 in for y and 2 in for x. So does everybody understand how I got the first step?
Yeah.
2 went in for y, 2 went in for x. And to get a by itself, you divide by b squared. So here's a. Here's your a value, 2 over b squared. All right, then you do it again. Standard form, y equals a times b to the x. Take this point, the second point, plug 4 in for y, 3 in for x, but now use the value that we got for a over here and plug it in for a. Okay? So 4 equals 2 over b squared times b cubed. And when you divide b cubed by b squared, what are you left with? b. b cubed divided by b squared is b. That's where I get 4 equals 2b from.
Why do you divide b squared by b squared?
b cubed divided by b squared.
Why are you dividing?
Because b cubed's in the numerator, b squared's in the denominator.
No, okay, it doesn't make sense.
It's like multiplying 2 over b squared times
Yeah,
b
it
cubed
looks
over
like-
1.
Right. If you want to put a 1 under here, that's fine. Alright? So then, to solve for b, I divide by 2, b is 2. Okay? Take that 2, and let's figure out the value for a. What's 2 over 4? Because 2 squared is 4, so 2 over 4 is 1/2. And once you get there, you're done. You know your a and b values. You got a value for a, you got a value for b, and that's all you need. X and y are unknowns. So here's your equation. Y equals a, 1/2, times b, which is 2, to the x power.
How'd you
Yeah,
get the 1/2?
I plugged 2 in for b. What's 2 squared?
4.
4 was 2 over 4.
Oh.
1/2.
And how did you do the, when you said 4 equals 2b squared, what did you do with the
No,
exponents?
4 equals 2b.
I mean, on the first step, how did
Right
you,
here.
how did you get?
This
two?
divides out with this. You subtract exponents. 3 minus 2 is 1.
Oh,
Okay? Alright, this one's pretty simple. We've already talked about this. All you have to do is determine whether the equations in blue are growth or decays. And all you do is look at the growth factor. What's the growth factor here? 0.12. So it has to be a decay because it's in between 0 and 1. Okay? Here, what's your growth factor? 5, so it has to be a growth. Here, what's your growth factor? 1/2, so
anything
it's
more
a
than
decay.
one's gonna be growth?
Yes.
Is 1 growth?
No, 1 would be linear. It wouldn't be an exponential. Okay? Here, this would be a what? No, it's a growth. Because A is negative and B, A is -1 and B is 2. Okay? All this would do is reflect it along the y-axis.
Wait, how's that?
This is a growth.
Oh, it's a growth?
Yeah, because your growth factor is positive 2. Your A value is -1. Yes, ma'am.
you just, so b would be 2, just 2.
B would be 2.
And the a value would be -1?
It can be 1 at all. Yeah,
Oh.
yes, the A value is -1 in that. Alright, and the last example, this would be a decay, and the table that I would give you here for a decay would be -2, -1, 0, and 1. Make sure you understand how I got the y values there. If x is -2, what's 1/2 to the -2? Look to the right. It's 4. 1/2 to the -2 is 4, right? Because of this. And 4 times 4 is 16. What's 1/2 to the -1? 2 times 4 is 8. 1/2 to the 0? 1 times 4 is 4, and 1/2 to the 1 is 1/2 times 4 is 2. Does that make sense? Yes.
How did you get the 1/2? How did you do that?
How did I get what?
4?
1/2 to the -2. You can't have negative exponents. How do you get rid of a negative exponent? You take the reciprocal of 1/2. So it becomes 2 to the +2,
Oh,
which is 4. So this is 4 right here times 4 is 16.
okay.
Alright, then just plot your points. You don't have to be exact. If you get really large numbers, which you will in the homework, then you might have to change your scale. Okay? Now, for both of these curves, the one we graphed before and this one, at this point right here, you will never cross this line. You keep approaching it as you go on, but you'll never get to it. Alright? And that definition is right here. Asymptote. A line that the curve approaches. In this case, we have a horizontal asymptote. We'll talk about vertical asymptotes later, but for exponential growth and decay, you have horizontal asymptotes. And if I ask you to write the equation of the horizontal asymptote, it would be right here. The equation of any horizontal line is what? Y equals. So in this case, and in the previous case, you had a horizontal asymptote at y equals 0. Okay? Any questions?